Alright, this is 3D Viewer, this is that other software. This just lets us view models really easily, and you can also, it's also, again, you can 3D print through this. It's just, it's good, it's useful, it's very informative, it can tell you a lot of data about what you're looking at, and, you know, what's going on with your model, etc. And it's good shit. So, let's go ahead and open up our model. Do open. Save it to the desktop, I believe. This one here. Okay, here we go. Got it. Normal. And this is that thing that we just made in Blender. So yeah, this is just a kind of me showing you some other stuff that you can do for photo shooting and stuff. Is you can, it's basic, you know, it's fast, so they have these different lighting options and stuff that you can play around with, and there's a fair amount of customization. You can rotate it and then change individual light colors if you want, and it's just good for understanding shapes and stuff. It's pretty useful. Change the environment's reflection and everything. But yeah, so there's not a whole lot to this program. I just kind of wanted to go over it really briefly. And it's very useful just because it loads quickly. Like if you just want to look at a quick model, just to see what's going on, and you know, you can see here, and it's pretty good. And you can use that as an inspector. Like I said, there's not any harsh geometry in here, or something that looks like unstable kind of with polygons, so we're good to go. And I will swap over to the slicer now. Okay, really quickly, I'm going to make another tutorial paired with the slicer video, so you can learn how to model things organically in Blender. Okay, so let's go over Blender really quick. So first thing is it's free and it's on Steam, which is really good. It takes up like no space, although the files you create in it can take up quite a bit of space, so it just depends. Another thing is, well, actually, that's kind of it. Oh, no, my bad. Okay, so think of Blender like a Swiss Army knife. It's good at a lot of things, kind of too many, and sometimes it's more efficient just to use whatever tool that you need to fit the job, kind of thing. So, like, for example, if you're cutting tape, it might be less efficient to use a multi-tool, because you would have to get the scissors out and unfold it and everything, whereas with scissors you can just cut the tape. So it's just a trade-off of preference, but I would not personally view Blender as like a pinnacle of everything that should be worshipped as the top tier program, because it's a very useful and versatile program, but it has a lot of limitations and a very steep learning curve too. So that being said, okay. Well, Blender's being a little bit odd. The zoom function doesn't seem to be wanting to work. There we go. Okay, I'm not sure what that was about. Okay, so like I was saying, oh my goodness, excuse me. Let me just get him out of here. Alright, so basically, right, you want to start sculpting in Blender. So let's say we want to sculpt something kind of like an arm. We're going to need something to start with. So up here you can go to in object mode, because you're basically just doing objects like for the main portion of the thing. So we can go ahead and do add, and we can click on basically these three are the ones we're going to be using, sometimes volume too, but so mesh is basically like what we're going to be using. So for an arm, let's go ahead and start with a cylinder, I'm going to say. Okay, so we have a cylinder in here. Now let's say we want to rotate it. So we can go up here and do rotate, or we can hit Shift spacebar R, and we can rotate this like this. I think this is going to be the forearm, for example. Okay, I know it's rough, but bear with me. Let's go ahead and add another mesh, and we're going to do the same thing, a cylinder. We're going to move this one, so you have to go up here to the move thing. And we're going to rotate this one also. We're going to go like this, okay? Now, we're going to go into edit mode. Edit mode lets us, let's go over the terminology real quick. Okay, so you can see when I clicked onto edit mode, firstly, this one has all these details now and this one doesn't. And that's because you can only be selecting one of these shapes at a time. And you have to do that through object mode. So if you want to select this shape, you'd have to go like this. Then you go back into edit mode and see how the details are on this one now and not this one. So we'll start with this one, that's fine. You have a bunch of tools on this side that can do various things. We're mostly just going to be using bevel for this one. So let's, similar to Tinkercad, you have extrude, inset, and all of these things, and just play with them. That's the best way to learn how each one works. Up here you have your different selection things, and it's kind of stupid how small this is, but basically vertices are when there's a point. That is a vertex because there's lines here that make a point. That's a one-dimensional object. We have lines, or what do they call them? Edges, okay. So edges are these lines that go in between 2 points. Those are 2-dimensional things, I think. Yeah, they are. Yes. Then you have faces, also 2-dimensional, but they encompass the volume or area in between edges to make polygons. So knowing that, you can select either one of these three to select whatever you want to edit, and this is really good for extremely detailed editing. So for what I'm going to do is we're going to select our face, and we're just going to select this guy here, this face, right? Now you can extrude it like this, isn't that cool? But now let's say we want to bevel it. So we can do that, and like if you go too crazy with it, you can get weird results, but for the most part, I actually made that too short, so let's go back up to extrude. We're going to make this nice and long, and then we're going to bevel this by dragging. Okay. It's okay, so it's not doing exactly what I want it to do, but it's really not that big of an issue because I'll show you something that you can do to fix it. So we're going to make it small like this, okay? Then we're going to come in here and we're going to select all of these noobs like this. So it's okay, sometimes stuff like this can happen, and it's just, again, it's a limitation of the software, and I am not proficient. There are wizards out there that could have selected that with one click, probably. But anyways, so now we're going to right click, delete faces. Okay, look at that. Now there should be a sweep thing. Poly build, use multiple. Maybe I didn't think this through. Cut new topology. Oh wait, no. Okay. Spin, smooth. Oh, you know what? We can probably do the extrude for this. So if we go down, see, this is a little bit more tricky because I've re-recorded this a few times now, and this is the first time doing an arm. But it's okay. We'll figure something out here. So basically, what I'm trying to do is connect these to this. I forgot how you be like this. Ah, okay, yes. I believe that this is how we do it. dragger. Looks like we got a drag. Okay. So again, oh wait, what's this? I want to be on edge select here. Damn it. Maybe on face select. Okay, I don't know exactly what is going on here. There should be a way to where if I do this maybe. No, what the fuck? Okay. If I do this and we move this over here, and then I scale this down by itself. Yes, okay. That's doing what I want it to do. So that's good. Now, I don't know how we would connect those two, but that's a start at least. So, I'm just going to focus on the forearm for right now because I don't want this to go like crazy ridiculously long for you, because you can figure a lot of this out by exploring it, but and now I can't delete that face. It's such an interesting program sometimes. There we go. Alright, faces, goodbye. Okay. So let's go ahead and start working this out a little bit. One thing is we want to close this up somehow. I think we can do that with a thing like this. Shift left, okay. I'm sorry, this is not going as well as I imagined it would be going, but it's sometimes you just gotta deal, I guess. Interesting. Okay. This is kind of pissing me off a tiny little bit. Alright, it's, you know, it's, I'm not gonna fuck with it, it's fine. So, let's just get on with this. So let's talk about modifiers. So, we can sculpt either one of these if we go into sculpt mode here. And also you have a bunch of tools, it's just some of them are hidden. So look at all these tools that you have. So, let's say we want to edit this and sculpt it a little bit. Let's use this scrape brush kind of thing. So if you go really high, which one is it? This guy, okay. Go really high, we can see that we're making very minute changes to this sort of arrangement here. And you know, that's just rough to really show. But there's a problem though. You notice like we don't have a whole lot of control over this. We can't exactly you know, it's not very responsive. And the reason is because we have these tessellations, like I was saying, and we have very little of them, and that's not as much data that we have the opportunity to manipulate. So the way to fix that is you have to make more of these tessellated bits, these polygons. So how you do that is you use modifiers. So what you're going to do is you're going to go into object mode, and you're going to click whichever one you want to do. I'm going to do this guy just for, let's actually delete this guy. We're just going to do this one to start with because it's a little bit simpler. So go into modifiers and click the little gear thing. We're going to go add a modifier. And you have all these different things, and I'll go through them real quick, just the subtypes. So editing is for like really specific stuff. A lot of it has to do with the data and all the raw input stuff and texture values and everything that has to do with rendering and like video game stuff, kind of a thing. Generating is more CAD orientated, which we're going to be doing today. Deforming is like general stuff that you can do to help automate certain things and like do very basic physics things. Like you can make something buoyant, for example, or just kind of odd little weird things, and also deforming things, so like changing the way that a surface looks or behaves. Normals are, I don't actually know what normals are. I used to know, but it has something to do with the mesh thing. God damn it. Fucking. Okay, there we go. Physics, that is pretty self-explanatory, and hair is also self-explanatory. So, generate. You have all these different guys, and these are fairly universal terms across CAD things. And if you notice these little icons here, I know they're simple, but they really do, they can do a good job sometimes of telling you what each one of these does, which is useful. So today we're going to be mostly using the subdivide surface and the remesh, and I will go over the subdivide first. So as you can see, when I clicked on that, it did a weird thing. So what it did is it subdivided, and if we basically turn that back, it's going to take every single one of these faces and cut it into 4 bits. And then when it's cut into 4 bits, it will be done. And that is what that looks like. It's using this thing called a Catmull-Clark, which is just a subdivision scheme, and it's kind of like an algorithm that decides how the shape will look. But you can switch it to simple, and look, it looks like nothing changed, right? But as we... That'd be funny if it fucking doesn't work with, oh no, it worked. Okay, that's good. So it looks like it didn't work. It's just because it's a thing. But anyway, let's apply this and I'll show you. So now, if we go back into sculpt mode after applying that, let's pick this one. And look. Do you see how we can carve into this shape now? And do you see these kind of pixely looking things? Those are just tessellate lines, or polygons that have formed inside of these. You can see they're all even and mathematical, and that's great because it allows us to sculpt things really easily and efficiently. Now over here, this is a little bit of a tricky shape to do this with before any post-processing. Like this corner is a little goofy. You can technically smooth it out though, and it'll be fine. So let's talk about ripping. So ripping is whenever you are distorting a model so much that... Oh, it's starting. Let's see. Make it kind of cool looking, I guess. Like a abstract sculpture sort of a thing. And I'm just like, this is really quite like just random and unscripted. I'm just doing this to show you. Okay, that looks pretty sick actually, but as we can see, we have this weird polygon shit going on here. Believe it or not, this one is actually okay. These are fine. But you can see it up here, you get some compression, and over here you get ripping. So this is actually good because it's showing multiple different kinds. So compression is pretty much self-explanatory again. If we zoom in, it's compressing all of these polygons into like a feather pattern, and that's very unstable. Like if you were to try to 3D print that, it could actually mess up the printer quite a bit. This is ripping. It's the opposite. It's when there's not enough polygons to spread out fully, so they rip. kind of like dough almost. And it's weird because it confuses the program a lot, because technically these aren't ripped, it's just they look ripped and they are. It's something called non-Euclidean geometry, and non-manifold surfaces, where basically the computer can't understand it, and we can't either, really. Like, this couldn't exist in real life. This is strictly something that can happen in a digital environment, and in math, but just not in real life that we know of. So they call it non-manifold artifacts. But good news is, this is really cool, and also there's no going back. Like, if you fuck up a model this bad, there is no way you will fix it manually. Look at all that fucking complexity. Even if you were to go into edit mode and manually, like a fucking duck, and I have done this before, unfortunately, sometimes it requires you to do. On some models, you have to manually sort that out. Look at that fucking thing, dude. That is complex as shit. You can do it. I have done it. Because I tried to 3D print a Archangel sword from Supernatural, and it had dithering and stretching at the bottom, and it looked very similar to this one, actually. And basically, it was just like constantly rotating all of these different planes until it fixed itself. There are more efficient ways to do it, but for my thing, I had to do it that way. But this is a cool shape. Like, we don't want to give this up. This would be very interesting, like as a centerpiece or something to 3D print, or just whatever. It's just an abstract form. But we have to fix this if we're going to produce it and if we're going to use it realistically. So the way that we can do that is back into object mode now. We can do the second modifier that I was talking about, which is the remesh modifier. All this does is it's going to take the entire model and it's going to decide how to, like, basically, if there's all this junk over here, it'll just be like, fuck it, and kind of asphalt over it with new stable polygons. And I will show you. It's not always perfect, but most times it'll fix almost anything. Yeah, okay, so it fixed it. Now I know that it looks fucked up, but it's just because it's on these different settings here. So if I were to change it to this, and we were to increase this quite a bit, maybe to, let's do 8, although that is pushing it. Okay, so now I know this looks kind of crazy. Let's turn it into blocks. This is kind of cool. You can do this. You can actually make Minecraft models in Blender and then import them into Minecraft. Because that's voxels. That's just blocks. Looks like a fucking massive ship or some shit. But this is more stable now. There are some holes up here, but all of that craziness has been reverted back to simple, reproducible geometries, and in this case that is voxels. But you can change it. You can go from voxels to smooth things. I might fuck up my computer here switching at 9 iterations up here, because I'm working in the powers of 9, so that's 9 to the 9th power. It's a lot of data, but it's more efficient than what it was when it was all fucked up and dithered. Now this one I really pushed the limits. You can see that there's some scarring, which is a really fascinating thing. Scarring is when artifacts that get fixed still leave a fucking effect on the new one. And sometimes that can be really cool. Like, I think it looks like kind of coral or something here, but other times you might not want that if you're making something smooth like a car. And this is, again, you could just go into sculpt mode and fix that manually by using a smooth tool. So let's try the sharp one and just see. Like I said, I really pushed the limits of this, and you can see that we're still getting some staggering. So you might have to actually do this like twice. But sometimes what you can do is, let's see if we can get it. Threshold. Change this to like, oh, it's as high as it goes. Okay. Fuck you. Sharpness. We're gonna turn this way down. Like, let's go to 0.4. Yeah, okay, I might have fucked this one up like permanently, but if you do this with something um, less amplified, like you're sculpting an actual arm, for example, it won't do this. But voxels are actually fairly stable for this, though. It's just this shit is a little bit irritating, but it's fine. We can fix that in another program. But yeah, that is basically the extreme basics of sculpting. And also you can use Boolean functions, which I will explain in another thing, but that's basically you can connect one thing to another using a command. And it's very easy to do. It's similar to Tinkercad. But yeah, so if you wanted to keep sculpting this, right, let's go ahead and apply this real quick. And we can, I'm curious if we remesh it again, what will happen. It seems like it gets a little bit more stable, but we lose some of that detail. So we're not going to actually worry about that, but we are going to subdivide it and make it have a higher resolution so we can fix some of these sharper edges. So let's just do 2 iterations for now. And we'll keep it on Catmull because it'll smooth it a little bit for us, which is, you know, doing some of our work for us, which is good. We're going to apply this, and then we're going to go into edit mode, or sculpt mode, my bad. And let's find one of the smoothing things. Where would it be? Grab silhouette. Where? Inflate. Oh, that's cool looking, kind of. It's okay, this actually might help us fix some of these issues. So I know it looks ugly right now, but there's just all these different ways to do everything similar to how you can in CAD. Although that kind of looks cool, it's like a hybrid of textures now. I don't know, I kind of like that now that I like think about it, look at it more, I guess. I don't really know what I'm making. This is just like purely 100% abstract for an example. So don't like take this with a grain of salt. But I mean, also look, like this would be pretty cool in like Deep Rock Galactic or some shit. Maybe as a thing of coral or some shit, right? And look, I'll show you in a second. We can make it look more. Look at that! Isn't that interesting? That texture that it's made now. So we can go ahead and add another modifier, and let's make it a little bit more stable by remeshing. We lose a lot of that detail though. Okay, so I've started recording again because it's leveled out now, that it computed all of that data, and as you can see, it is, let me fix that glitch real quick. There we go. As you can see, it is perfectly stable now. And you know, that's pretty cool. So I actually want to print this out. I think this is a very interesting looking thing. And there's such a variety of texture because of what the algorithms did to this. So you have these like ball things up here. Oh boy. Maybe it's not as stable as I thought it would be. Unless it's doing the glitch again. No, it is definitely fucked. Alright, knock on wood, I think... Oh man, I don't know. Okay, I think it is stabilized. So don't use the decimate command. I found out that that actually increases the polygon count even more. So this is already at 55 million polygons, which is crazy. That is a lot of polygons. And also, I am going to print this out because I think it is just an interesting thing. There's a lot of variety of texture from what the algorithm did. Look at that. Isn't that interesting? I think I'm going to print this in copper, and we'll just see how it looks. But this is just a really good kind of base thing to understand like what it does. And honestly, I want you to play with these to figure out what all of them do, because I'm not even sure. I mean, some of these are really crazy. Like, yeah, that's pretty wild. So I kind of want to fuck with that now, but probably shouldn't. Oh, that looks cool. Okay, I'm getting like hella distracted by this, but still. Yeah, there's so much you can do here. So just see what you like and what you can do, and try to model things that are like bigger and smaller. And I'll do another video too showing how you connect two pieces that are simpler. But let's get this prepped for exporting, and I'll show you how to make it a little bit more manageable, because 55 million polygons is not manageable. This file would probably take a couple gigabytes on your computer, so let's go ahead, and we're going to use a modifier again. So one thing we have learned is the remesh modifier works pretty well to do this. We can also... Which one is it? It's like a simplified thing. Procedure. You know what? It's all good because we can. It's the opposite of. Let's do this. Let's try triangulate, I guess. I fucking should have saved it before I clicked that. So this will make it a bit more stable. But it's still a really just crazy high detail, which I'm not a fan. Like, look, you think that these are the triangles, right? But then you zoom in, and these fucking edges have triangles on their triangles. It's really crazy. So instead, we're just going to do this in a different program, because I'm not sure how to do this in Blender stably without it crashing. But there are other. This is kind of what I was talking about earlier. No, this is great. I'm glad this is in the video. So this is exactly what I was talking about earlier, where Blender can be over-specialized for its own good. Like, you can make suicidal moves in this program where you make a model like this and you're stuck. You can't do anything because it is so resource intensive that if you edit anything, it will crash and you'll lose your data. So, it's, again, Blender is a really good tool, but sometimes it pushes into itself with its limitations. So we're going to move it into a different software, which you have to learn anyway, that is really specific and good at reducing meshes and simplifying them for 3D printing. So I'm going to jump over to that now. Sorry, no I'm not. I am actually going to show you how to export this properly so we can jump over, so my bad. Okay, let's export this really quick. So we're going to export it raw, 55 million. This will be a good example of how data dense this thing can get. So you're going to go up to File, and you want to export. And just like in the Tinkercad bits, you have obj and stl, and you also have this bonus one, ply, and there is the glb thing. You're really only going to use stl and obj. You might use ply occasionally, and you very, very rarely may use gltf, but it's so rare. So we're going to export this as a obj because this is an organic shape that has a lot of detail. And if we did it as an STL, the STL would be not data friendly at all. So we're going to go ahead and just do this like weird egg thing. And that's it. You just do export as an OBJ. And this is a bigger file, so expect this to have to cook for a second. And you can also check here. Oh yeah, okay, it is still recording, good. Sometimes it cuts out whenever I switch to the program, so I don't know if you just saw, but it said that it did it successfully. So I'm going to jump over to the program. Alrighty, and here we are in revoscan. So revoscan is the software that is also free, that is for the 3D scanner that I use. This software is really powerful past that of the scanner, because it has these really cool tools that are super specialized, like scissors, in dealing with really hard to deal with things. And I mean, look at some of the megabytes and stuff on some of these parts are quite beefy. So yeah, let's go ahead and start. So this is also, again, same thing with Blender, or like Blender, it's free, so you can go on and get this right now if you want, and you don't need to 3D scanner or an account or anything to use it, so it's nice. New project. Let's just call this the egg thing. Okay, so here we are. Up here are your basically all the tools you're going to be using. Over here is the specifics of the tools, and then over here are like selection tools, and that's basically it. This is a very simple software. It's easy to learn. So up here we're going to do file, and just like how we did in the other ones, we're going to go ahead and do import, and we're going to look for that thing that we did. Let me test it with the duck first. Actually, no, we'll do it with this. So now this is a dense model, so this might take quite a second. I'm actually going to cut the video and let it. Okay, we are here sometime later, and hopefully my PC isn't fucking up the audio. You can see that we're here, and we have a ridiculous amount of fucking polygons. It's actually way more than I thought it was. It's over 100 million, so that is, or my bad, 11 million, I'm stupid. That is still a ridiculous amount. So over here we have basically these. You don't have to worry about these. This is more for the scanner side of things. So isolation, if there's a floating bit, it'll detect it and delete it. So we can, let's start with simplify, just because this is a really evil model for the computer to handle. So it's math. This is basically how it works. If you have this many polygons and you reduce it by 40%, it's only going to remove 40% of those polygons. So this is really beefy. So we can always go back. Let's start at 80 or 90, because that'll delete 90% of the polygons here, which, again, 11 million is really crazy, so this should be fine. I'm gonna just keep pausing this because it took about 5 minutes for it to load last time. So okay, it has been a little bit of time, and luckily the mesh has been simplified from 11 million polygons to 60,000, which is child's play for a computer, so it's fine. And we can still see that a lot of the details have still been retained pretty well. There's not a big loss, and that's because we went... Oh, what is that? Okay, perfect. I'm glad that this exists. I'll show you in a second. So that is a non-manifold artifact. We talked about those a second ago. Let's see if there are any more. Not... Oh, what's that? No. Oh, yeah, there's another one. Okay, so it looks like 2. That's fine. We're going to fix them. Sometimes it happens. It's just, again, just a lot of math changing over time. I love some of the texture that this just got from the algorithms, honestly, but it's very interesting. So first, we can do isolation. And isolation, like I said, it'll detect anything that's floating. And there we go. Okay, look, see, this bit was floating. Now, if we tried to 3D print that, that piece would need support, and it's really small, so it's not feasible. So again, this is very useful because now we can just apply, and boop, it's gone automatically. None of that selection or isolation stuff we have to do in Blender. Secondly, do fill holes. You have curved and planed. So first, let's just detect. Holes are everywhere. Look at that. And these are those non-manifold edges that I was talking about. So let's zoom in and inspect these real quick to get a better understanding of them. This is a polygon that's corrupt. It basically flipped up and bonded to one of the vertices up here, and now it's made this negative hole shape that can't exist. And it's pretty common. Like I said, we're reducing a lot of data, so some things get cut. It's kind of like whenever you have a high image resolution and you squeeze it down, that sometimes the edges don't look that good. So it's the same thing, it's just more complicated with 3D models. Luckily, we have tools to help us fix these. So for one, you can hit Control A, which will highlight every single one of them, which is nice because you don't have to click them manually. So let's just go through it. It's very straightforward. Plane, if you have this selected, it's going to basically fix these and replace it with a flat surface that fills this up, right? So if we go ahead and do this real quick, you can see there's just a flat surface now, and that looks like a fucked up edge, but that's actually okay. For what we're doing, that'll work fine, but I'll just show you the other one. So curved will do the exact same thing. It's just it'll try to average this out with Boolean math, so it's more natural looking. This doesn't matter if you're working on literally like one polygon, but for massive objects it can make all the difference in the world, because sometimes, like, if we were to cut, I don't know if I can do that. Let me see if I can do that. I might actually be able to. Look at that. Okay. So I had just made a colossal basically wound to this model by just ripping out, like, this isn't even a smooth edge, and that would not be able to 3D print because it's a zero manifold interface. So we can go ahead and do the hole fill thing again, right? And so let me show you what happens if we do plane. Let's just do this one. If we do plane and we fix it, it's gonna do an okay job, but it looks fucked, like, from a distance. It's like, what the hell happened there? It looks like a shit streak. So back up a minute. And again, it's not a perfect thing, but definitely this is what curve would be used for. So now if we do this, it'll use Boolean math and try to make that more uniform. And if you zoom out, it's still noticeable, but much less so than before. But we don't need to do that because this model, okay, there we go, sorry. So let's just detect all of the little holes, and we're going to fill them. And then to make sure it didn't make any more, because sometimes it can, we're going to detect them again, and there we go, we're good to go. So this can be exported to 3D print now, and it's stable, and it's meshed very nicely. Like, if we look up close, these meshes are really precise and good. So it's a good model. So we're gonna, same thing, export, do mesh model, and then we can go to downloads and we'll do weird egg thing mesh fixed. And this is important. It's gonna auto save it as a PLY, which is a point cloud logistic thing, and you don't want that. For 3D printing, again, OBJ is probably best for this model, but STL will work as well. So let's do OBJ. Oh, you know what? Whatever. Fate has had it. So it'll be good to compare the data size anyway to the original. So okay, good. And now we will go to. All right. So let's go ahead and load that in. This is the fixed one. And Blender has this habit of making things very, very small, but it's not a problem because, again, we can just scale this up to be much. Well, we're supposed to be able to scale this up much bigger. Yeah, there we go. Okay. I'm going to make it kind of small, so we can you know. Okay, let's go ahead and audio orientate it, because I bet it's going to flip it. No, we're not doing that. So again, rotating it, we want the spindly bits at the top, the big fat bits at the bottom. So we're going to go here, I'm going to go like that. Okay, because now we won't have to put nearly as much support. There will have to be support here, but that's okay. Alright, so let's go ahead and slice it. So firstly, I'm going to change something in the setting, and this applies to Cura too. I'm going to print this in copper PLA. So copper PLA has silk in it to make it look shiny. So what I have to do is, you don't have to, but if you switch this to PLA silk, it will print a lot better, and it'll look a lot nicer too, which is good. So for infill, sorry, just wanna, because I don't really care, this is a strictly representation of parts, so we're just gonna do fucking 9% infill, and that should be plenty. So if we slice, let's make our supports, right, enable tree supports on build plate only, and we should be fine. So we're going to slice the plate now. Okay, that looks pretty cool, pretty dope actually. So yeah, let's let it print, and I will see how it comes out. But you can see, obviously you're going to lose some of the detail with the 3D print. But yeah, that is basically it. I mean, we made that in Blender in I think maybe 20 minutes or so, and it's already ready to 3D print. Now it gets more complicated with, like, you know, prosthetics and stuff, but the thing is you can use the scanner and all these other tools in combination with Blender and other tools and get different results. Because, like, let's say we could scan your body or your shoulder or something, and then we could import that data into Blender, and you could sculpt around your body in a virtual environment. And now, like, it's getting even crazier. Like, you can do it in VR. So, like, you could scan your body, import it into a VR CAD program, and scale it up to be the real size of you or someone else. It doesn't matter. And then you can just basically do CAD in VR as if you're working on, like, a doll or a person or something. It's very interesting. So yeah, this is just strictly a quick demo on how to just kind of jump into sculpting. This is not really anything you have to like. It's not super specific, and obviously experiment with it and just see what you can do with it. I've played with the sculpting mode a few times. It's pretty fun. So yeah, and don't be afraid to experiment with different modifiers and see what they do. Blender tells you what everything does. You might accidentally make a fuck up move and crash, so save your stuff, or just don't be that attached to it. Like, I'm not attached to this egg. So, you know, I'm just printing it just as a proof of concept kind of a deal. So that is just something to keep in mind, and I will print this, and yeah, we'll see how it goes. But yeah, the next video will probably be with Blender as well, and we'll jump into a little bit more of the sculpting stuff, and then also specific. I'll sharpen up on the specific face modeling and everything. But this should hold you off for a while and keep you occupied. So yeah, good luck.